Now we want to make a formula so that if we will give formula to anyone, they will be able to generate the next term. So can we say that the formula will be an will be the previous term plus 2? Can we say, Ali?
Yes, ma'am.
But we can generate a formula from the above example that an, if you want to find the second term, you have to take the first term plus 2. If you want to find the third term, you have to take the second term plus 2. If you want to find the fourth term, you have to take third term and then you will be adding 2 with it, you will be getting the next term. So we have generalized a formula over here. Like this in first exercise, all the this type of formulas are given. Like an is this is how the sequence is defined. Please find the first 5 terms or maybe first 3 terms. So let's do few questions which is very basic. Our sequence here, the instruction is like this: write the first 3 terms in each of the following sequences. First one is an is defined like this: an is equals to n minus 3 by 4. Okay, we can take n as, we will be taking n as the first, like the first term, the second term, the third term, like that. Okay, n is the number of like which term we are talking about. With the help of this one, we have to generate the first 3 terms. So if we want to find the first term, that is a1, can you tell me, Ali, what will be the first term?
Ma'am, it will be minus 1 by 2.
Yes, it will be. Okay, 1 minus 3, that means minus 2 by 4, that means minus 1 by 2. Can you tell me the next term and the next term?
Minus 1 by 4.
Minus 1 by 4. Next.
0.
Okay, so this is how we can find the first 3 term, which is very simple. Okay, this is what the sequence look like. The first term is minus 1 by 2, next is minus 1 by 4, next is 0. Okay, now the next question. Suppose I am giving you an is equals to 2 to the power n, and still I am telling you write the first 5 terms. Okay, first 5 terms. Please find it again.
Ma'am, 2, 4, 8, 16, 32.
4, 8, 16, 32. Okay, yes, perfect. Okay, so I can see you will be able to find any terms, whatever will be given. Now the one of the question is like this. The Fibonacci sequence is defined like this. This is how our Fibonacci sequence is defined. Okay, this is very famous sequence where the first term is 1. Okay, the next term is 1 because A1 and A1, A2 clearly it is written over here 1. Even if it is not written over here, this is such a famous sequence. Okay, 1 1. Now the next term we'll be getting by using this formula. So basically next term, even if you will use the formula, we will be able to find, or directly also I can write the sequence. Okay, let me take it out from the formula. So suppose you want to find the third term, that means 3 minus 1, that means you have to use second term plus you have to use 3 minus 2 first term. Our second term is 1, our first term is 1, so the next term will be 2. Okay, next term will be 3, next term will be 5. How I am saying it, next term will be 8, because in this famous sequence whose name is Fibonacci sequence, here the next term we are getting, which is the summation of the previous two terms. 1 plus 1 added together is 2. Now the next term 3 is the summation of previous two terms. 2 plus 1 added together, this 2 plus 1 added together is making 2 plus 1 3, and that is the next term. Now the next term, this 5, this 3 and 2 added together is creating this 5. This 8, this 5 and 3 added together is creating 8. Now can you tell me three more terms over here, Ali? Yes, without using this formula by yourself.
Ma'am,
Can,
13, 21, and 34.
okay. So this is how the sequence is designed. Okay. For this sequence, the formula is given over here. And the question doesn't say to write the sequence. Okay, this is just the extra. This much is the question. And here it says that after this one, it says that find a n plus 1 by a n for n is equals to 1, 2, 3, 4, 5. Let's do it. Let's find a n plus 1 by a n when n is 1. Then when n is 2. Then when n is 3. So one by one, we'll be finding. Okay. A n plus 1 by a n. When n is 1, a n plus 1 by a n. It will be a 1 plus 1 by a1. That means a2 by a1. Basically, we are supposed to find a2 is 1 and a1 is also 1. So the result is 1. When n is 2, can you tell me, Ali, what are you getting? Similarly, when n is 3 and 4 and 5. This is what we have to find, a n plus 1 by a n.
Ma'am, is it 2 by 3?
an plus 1 by an. Third term, yeah. Wait. Third term by second term, right? When n is 2, it is 2 plus 1 by 2. That means third term by second term. Third term is to see by the formula also you will be getting the third term as a 2 only. Okay. Third term is 2. But the second term was 1, right? Right, Ali?
Yes, ma'am.
Please find the n equals to 3 and 4 and 5 also.
Ma'am, it is 3 by 2.
3 by 2.
Then it is 5 by 3.
It is 5 by 3. Then
It 8 by 5.
yes. So this is how we'll be finding whatever an, whatever the formula is given for the sequence. Okay. If 3 term it is asked, we will find 3 term. If 5 term it says, we will find 5 term. N is what? N is the term, the first term, the second term, the third term, the fourth term. Like the in arithmetic sequence, you were saying that N is the nth term. Okay, so it is just telling us the term, the number of term, the first one or the second one, just like a rank. The first rank, second, third, fourth, fifth, sixth, 10th. Okay. Now geometric progression. We understand how exactly arithmetic progression looks like. Okay. What about this geometric progression? So basically, if our sequence looks like this 2, 4, 8, 16, 32, 64. If our sequence looks like this, is it in AP only?
No, ma'am.
It's not in AP. Okay, it's not in AP, it's in GP. How will we checking it's in GP? So in AP we used to check A2 minus A1, then A3 minus A2, then A4 minus A3. Here we will be checking like this. The second term by first term. Okay, and the third term by second term, and the fourth term by third term. Okay, basically any term with by previous term. If all the ratios are same, is it same?
Yes,
Is
ma'am.
it? It is same. Okay, ratios are same. That's called common ratio over here. Okay, that time we were calling the differences as a common difference. Here we are going to say it's a common ratio. Okay, it's a common ratio we are getting, hence the given sequence is in GP. So in GP we have to check whether the ratios are common or not. If the ratios are common, it's in GP. If the ratios are not common, it's not in GP. Let me give you few more examples. Tell me whether it's in GP or not. 1 by 9 minus 1 by 27, 1 by 81. There is one and only one criteria to check the ratio. If the ratio is common, it's in GP. If the ratio is not common, it's not in GP. Please check it. Yes, Ali.
Yes, ma'am.
It's in GP.
Yes, ma'am.
Okay, what is the ratio, common ratio? What ratio you are getting? If we will be doing minus 1 by 27 by 1 by 9, you can write as a minus 1 by 27 to 9 by 1. Minus 1 by 3, are you getting Ali?
Yes, ma'am.
Yes, minus 1 by 3. The common ratio over here is minus 1 by 3. Now you got to know that the terms can be positive, can be negative, can be fractional number. But basically, to declare that it's in GP or not, geometric progressive, it's in GP or not, we have to check whether the ratios are same or not. Ratio between what? Ratio between the second element to first element, or maybe the third element to second element, or maybe the fourth element to third element. If these ratios are same, then we can see yes, the sequence is in GP. Otherwise, it's not in GP. Now in AP, arithmetic progression, we used to represent the first term with A. Here also we will be representing the first term with A. Yes. Here also we will be representing the first term with A only. A means the first term. Now in arithmetic progression, we were representing the common difference as a small d. Here also we will say the common ratio is a small d. No. Here we will say the common ratio is small r. With the help of this alphabet, we will be representing our common ratio always. That is small r. Okay. Now if I will write the first example where I have given this example, 2 is there, then 4 is there, then 8 is there, then 16 is there, then 32 is there. Okay, then 64 is there, like that. Okay, it was in GP, we have already checked. The common ratio we have found, that was 2. Common ratio R is 2. First term A is 2. Okay, now from here I am just trying to show you a format that can you see that the first term is A, that is 2. The next term is A multiplied with the common ratio. Yes or no?
Yes,
Just
ma'am.
keep on matching by putting the value of A and R. The next term is the same AR, the previous one, multiplied with 1 Can you hear me, Ali? Can you hear me?
Yes, ma'am.
Okay. So for a So let me share the screen again. For a while, I am keeping the camera off, okay? Focus on the concept. So the next term, can we write it? Can you hear me, Ali? Please, you have to confirm me that, yeah, you can hear me. Okay?
Yes, ma'am.
Can you hear me? Okay. So the next term is the previous term AR multiplied with the common ratio. Yes or no?
Yes, ma'am.
Now similarly, we can also write the next term as a AR square. After that, the next term we can write as a AR cube. And after that, we can write the next term as a AR to the power 4. हमें हमारा नेक्स्ट टर्म कैसे मिल रहा है? एवरी टाइम हम अगर प्रीवियस टर्म में कॉमन रेशियो का मल्टीप्लीकेशन अगर कर दे रहे हैं, प्रीवियस टर्म हमारे पास 2 है, उसमें अगर कॉमन रेशियो 2 मल्टीप्लाई कर देंगे तो हमें नेक्स्ट टर्म मिल जा रहा है। ऐसे ही हमारा प्रीवियस टर्म 4 है, इसमें कॉमन रेशियो 2 मल्टीप्लाई कर देंगे तो हमें हमारा थर्ड टर्म मिल रहा है। ऐसे ही हमारा जो प्रीवियस टर्म है 8 है, उसमें कॉमन रेशियो मल्टीप्लाई करने से हमारा नेक्स्ट नेक्स्ट टर्म हमें मिलते जा रहा है। ओके। सो यहाँ से हमें एक जनरलाइज फॉर्मेट मिला कि जैसे कि हम अपने एपी को रिप्रेजेंट कर पाते थे ए A+D, A+2D, like that, A+3D, A+4D, ऐसे हम अपने एपी को रिप्रेजेंट कर पाते थे, वो हमारा जनरल फॉर्मेट था। यहाँ हम अपने जीपी को रिप्रेजेंट कर पा रहे हैं ऐसा कुछ जनरल फॉर्मेट में कि फर्स्ट टर्म अगर ए हुआ और कॉमन रेशियो अगर आर हुआ तो सेकेंड टर्म ए आर होगा, थर्ड टर्म ए आर स्क्वायर होगा, फोर्थ टर्म ए आर क्यूब होगा, फिफ्थ टर्म ए आर टू द पावर 4 होगा, और ऐसा कुछ हमें जनरलाइज फॉर्मेट मिलेगा। आर यू गेटिंग इट अली?
Yes, ma'am.
आर यू गेटिंग इट?
Yes, ma'am.
आर यू देयर? Okay, so this is what we are getting, the generalized format. नाउ यहाँ से हम एक चीज समझ पा रहे हैं कि हमारा जो फर्स्ट टर्म है, मैं यहाँ पे फर्स्ट लिख रही हूँ, ठीक है, यहाँ मैं सेकेंड लिख रही हूँ, यहाँ मैं थर्ड लिख रही हूँ क्योंकि ये थर्ड टर्म है, ये फोर्थ टर्म है। तो अगर हम अपने ध्यान से अगर इस जनरलाइज फॉर्मेट को देखें तो हमारा फर्स्ट टर्म में आर का पावर क्या है? 0। ठीक है, आर है ही नहीं, दैट मीन्स द एक्सपोनेंट ऑफ आर इज 0। हमारे सेकेंड टर्म में आर का पावर क्या है? 1। थर्ड टर्म में आर का पावर क्या है? 2, मतलब एक कम, थर्ड टर्म एंड द पावर ऑफ आर, द एक्सपोनेंट ऑफ आर इज 2। फोर्थ टर्म में आर का पावर क्या है? 3 है। फिफ्थ टर्म में फिफ्थ टर्म में आर का पावर क्या है? 4 है। मतलब जो नंबर ऑफ टर्म हम लेना चाह रहे हैं, वहां जो हमें वहां जो हमें टर्म मिल रहा है, वहां आर का एक्सपोनेंट एक कम रह रहा है, हाँ या ना? ऐसे ही फॉर्मेट अगर हम फॉलो करें तो क्या हम बोल सकते हैं अली कि nth टर्म में ए तो होगा, आर भी होगा, बट क्योंकि ये nth टर्म है तो n माइनस वन पावर होगा, हाँ या ना?
Yes, ma'am.
Okay, so from here we are getting the formula for nth term of GP. That the formula for nth term of the GP is AR to the power n minus 1. Randomly we are not getting the formula. Okay, there is a logic behind it that we have observed in the generalized format. From where we got generalized format? From the example we got that first term is A. Next, if the common ratio is R, then the next term we will be obtaining by multiplying A with R. After that, the previous term AR multiplied with one more R, it became AR square. After that, AR cube. After that, AR to the power 4. Now we started observing this pattern and we realized that, okay, then nth term formula, nth term of GP will be nth term of GP. The formula again I am representing with an the way we used to represent in the AP will be AR to the power n minus 1. This formula you have to learn it. That whenever we'll be finding nth term, we have to use the same formula. R is the common ratio, A is the first term, n is representing which term we are talking about. So far is it clear, Ali?
Yes, ma'am.
Now we can solve your question if it. Okay, we'll be doing this question. Okay, we are having a GP. The third term is given as a 24. Sixth term is given as a 192. I'm audible, right?
Ma'am, I cannot see your screen.
Okay. Yes, this is the. Now you can see, right?
Yes, ma'am.
Okay, in a GP, the third term is given as a 24. Sixth term is given as a 192, and we are supposed to find the 10th term. We're solving it like the AP question, the way we used to do. Let's write the formula for third term. Third term formula A3. The formula will be AR to the power n minus 1. That means 3 minus 1. Okay. This is the formula. The value is here, third term. So we can write is equals to 20. Sixth term is 192. So sixth term A6. Okay. Formula is AR to the power n minus 1. That means 6 minus 1. That value is. I don't know why again and again it is just reconnecting. Let me share again. Okay. So from here we can write that AR square is 24. And A from here we can write that AR to the power 6 minus 1 means AR to the power 5, that is 192. Now that in arithmetic progression, we used to think about how can we solve equation. Okay, here also we will be thinking the same, but that time we were using the concept of solving the equation by maybe by method of elimination or by method of substitution. But here in geometric progression, there you will put a over here. Yeah, that will be helpful. But better, what we can do, we can divide these two equations. Okay, adding two equation, subtracting two equation, multiplying two equation, and dividing two equation is completely acceptable. Okay, so we can divide this two equation. Better we will divide equation 2 by equation 1 because equation 2 r is having the bigger power. If you will do the division like this, no, it will cancel out your a and you will just left with r and you will be able to take out the value of r. You will be having a to the power 5 by ar square is equals to 192 by 24. You will just do the simplification here and you will be able to take out the r value. R cube is 192 by 24. Please check it. What are you getting, Ali? Same thing you will be getting when you will apply the method of substitution. You will take out a from one of the equation, put it in the other equation. You will be getting the same. You will find that your r is getting like reduced and a will vanish, of course.
Ma'am, 8.
Yes. What are you getting, Ali?
Ma'am, r cube is equal to 8 and r is equal to 2.
Okay, r cube is 8 and r is 2. This r we will be substitute. Wait, let's see what the question says. So find the 10th term. We are supposed to find the 10th term. R we are having in hand. If anyway we'll be able to find a also, then 10th term, finding 10th term will not be a big deal. So yes, we can find a by using equation 1 or equation 2. Okay, so let's use equation 1. AR square is 24. Here R, just put 2 at the place of R. We'll be having A into 2 square is equals to 24. That means A into 4 is 24. That means A is 6. We got A, we got R. Now we are supposed to find the 10th term. Okay, 10th term. So 10th term will be A10 will be AR to the power n minus 1. That means 10 minus 1. AR to the power 9. A we know, R we know. Please find the final answer, Ali. A is 6.
Ma'am,
R is 2. Yes,
3072.
3072. Yes, this is our 10th term. Is it crystal clear, Ali?
Yes, ma'am.
Let's do a few more questions. Which terms, which term of GP 2, 8, 32 up to n terms is 131072. Which term of GP, this GP is 13107. Okay. So we will say, let's say nth term. Nth term is this. Okay. So let's say an is this 131072, and we will be using the formula for an, that is a r to the power n minus 1. That is the formula for nth term. Okay. Do we know a? Do we know r? Yes, we do know a and r. Okay, a is 2 and r is only
R is 4.
r is 4. So a is 2, r is 4, n minus 1, n value we are supposed to find 131072. We will divide it by 2. A we can shift to other side. So 4 to the power n minus 1 is equals to 131072 by 2. 2 6 times 12, 2 5 times 10, again 2 5 times 10, 2 3 times 6, 2 6 times 12. This is what we are getting, right, Alu?
Yes, ma'am.
Now our job is to do the factorization, because this question is from exponent rule. We can use to this, we can compare the exponent on both side, and then we can, that is the only option to take out the value of that. So let me help you. We'll be having 2 3 times 6, 2 times 4, 2 7 times 14. Okay, 2 6 times 12, 2 8 times 16. Okay, 2, we could have taken 4 directly. Let me check for you. 4 8 times 32, 4 1 times 4 5 6 7, 4 9 times 36, 4 2 times. Yeah. Here also, if I try taking 4 2 times 8, then 0, 4 4 times 16 17 18 19, 4 8 times 30, 4 5 times 20, 4 1 times 4, 4 2 times 6. And 512 means 8 into 8 into 8. You know? Do you know?
Yes, ma'am.
Okay, 512 is 8 into 8 into 8. So basically this number we got like this: 2 4 4 4 8 8 8. We will try writing it as an exponent of 4. 3 fours we are already having. 4 to the power 3 we are already having. This 8 will give 4 into 2. So 1 4 will be getting. This 8 will give 4 into 2. 1 4 will be getting. This 8 will give 4 into 2. 1 4. Okay, 1 2. This 2 I am writing as it is. It's just the factorization I am doing my way. You can do your way. Okay. So 4 to the power 3 was already there. 3 more 4 we got, and this is also 4, and the first one and the last two, this is also 4. So let me check how many 4s we got. 3 4 5 6 7 8. 4 to the power 8. Check it, Ali. Comparing exponent on both sides, because the base is same. Okay, then only we can do the comparison of the exponents. So we are getting n minus 1 is equal